Here, let's calculate the amount of light that reaches a point on the plane that comes from all parts of the sky, or from a sky that contains the light sources from all of the points in it, or in the sky. So let's start with a plane. And the point of analysis. Now this point receives light from all parts of the sky, so that can be denoted as a hemisphere, or can be thought of as a hemisphere. Let's draw the circle on the plane first, and then the hemisphere. And light comes from all directions from this hemisphere or the sky to this point on the plane, for example. So this means that the amount of light that receives this point comes from the summation of all these lights from this hemispheric source, which means that we have to work with angles. So one angle is the direct light from the top at 90 degrees to the plane, and the angles of this angle is called the azimuth angle. So that is spelled as this. And then also from the sides, like that. And like on the plane, this is called the zenith angle, or denoted as phi, and spelled as this. Now to sum all of the light that comes to this point, we use integrals to do that, or basically just the sum. We start with the azimuth angle from 0 to 90 degrees, and pi over 2 is 90 degrees. We sum up all of the light in this direction, and forms this equation. We use the sign here is because the intensity of light that reaches from an angle is lower than the direct one coming from the top. So this is more like a factor that reduces the amount of light that comes from the side. And just for reference, the sign looks like this, from 1 to -1, where this is pi, and here is 2 pi. Now how about the light that comes from the side? That can be written as this equation, from 0 to 2 pi. Why 2 pi? Because of it's a circle, and it moves from the sides of the circle. And this simply equates to, from 0 to 2 pi, the difference of 2 del phi. So this equation relates to the amount of light that comes vertically in the sphere, and this equation is the light that comes from the sides, or the horizontal aspect of the sphere. Now we combine these two equations to sum up all of the light that comes to the point from this hemispheric source. So we do that by sum over the sum, so from 0 to 2 pi, and then the sum of the light that comes vertically, and then we close that. So there's one sum inside here, and there's another one at for the side, and this is equal to the amount of light, the area that comes from the hemispheric source. Now, the integral of the sine term is simply cos. So it integrates to cos pi over 2 minus cos 0 and then the integral at the outside. And another term here. So now cos pi over 2 is 0, while this is 1, which makes this positive 1. And then 1 is a factor, so it's a constant, so we can move this out of the integral, and then this term to integrate is quite simple. It just equates to 2 pi. So that means the area of the source, hemispheric source, is just the dimensionless area 2 pi. And we will be using this to calculate the amount of light that comes from this hemispheric source, because it relates to the area of that source to a point on the plane, or in this case, the Earth.